Welcome to our webinar, Best Practices in Hyperparameter Optimization for Developing High-Performing Models, brought to you by MLconf and sponsored by SigOpt. We're so glad that you are joining us. We are also very glad that our distinguished guests will be joining us, and I'll tell you about them in just a moment. But before I do want to note that during our webinar, we will give you the opportunity toward the latter half to hear responses to your questions. That said, you are welcome to type your questions at any time during the course of our webinar in the Q&A area of your console. I would also point out we will pose polling questions, and some of these responses to the polling questions will inform our discussion, so we very much look forward to your responses to the polling questions. In the meantime, and before we begin, I do want to tell you about our very distinguished guests who are joining us today. First, I do want to acknowledge the sponsor of our webinar, SigOpt, and both our distinguished guests are from SigOpt, and some background, I think, is definitely in order. So, by way of background, Faye Kaggle is head of product with SigOpt. She's an entrepreneur, philanthropist, and passionate product leader to SigOpt. She contributes more than 2 decades of experience incubating and scaling technologies, forming partnerships, and building revenue growth across mobile, advertising, and artificial intelligence industries. So looking forward to hearing from Faye. We'll hear from her fairly shortly. We'll also be hearing from Jim Blomo, head of engineering with SigOpt. He's an executive engineering leader who achieves strong business results in technology companies by creating a culture of performance, innovation, and teamwork. So we'll be hearing shortly from Jim as well. With that said, at this stage, it is now my pleasure to turn the floor over to our distinguished guests, both from the sponsor of our webinar, SigOpt, to our distinguished guests, Faye and Jim. We'll first be hearing from Faye, so please give a warm welcome. Thank you very much.
Thank you. Welcome, everyone, to our webinar today. What I want to do is really start by introducing our solution and share with you how you can get access to our product. And Jim will really dive deeper into how you can use our product, what are some of the best practices, really give you a glimpse on how to use SigOpt for building high-performing models. So first of all, what I want to start with is we went on the road and we spoke to about 100 practitioners in this space. We tried to understand the pain points today in terms of adopting machine learning in the enterprise. And the key 3 pillars that capture most of the pain points really pointed to a productivity need. There is a need for enterprises to be more productive, as evidenced by the fact that 75% of companies build their own models in-house. This really shows an underlying need for being able to capture and share insights across modelers. A second key area of focus for enterprises today to adopt more machine learning is the fact that it takes, on average, 6 months for models to make it to production, and that's a very kind of broad average. But 2 out of 3 projects actually fail. And this points to the uncertainty around modeling, the constraints of this multivariable space in which models get to be designed. And then lastly, we are coming to a place where close to 60% of enterprises will reach a mass scale in terms of bringing models to production, with about 20 models in production by end of 2021. And this particular trend is really pointing to how enterprises today need standard operating procedures really to be able to reproduce some of their works, to explain what transpired and how the model learned, but ultimately to comply with any regulations imposed in the industry. So our first poll for the audience is, what are your pain points today in your own modeling process?
Well, thank you very much for setting the stage, Faye, and indeed this prompts us for our very first of 3 polling questions. We want to find out what, as Faye said, what you're most pressing non-data related problem is today. And from top to bottom, here are the choices. First, tuning or selecting hyperparameters, defining or selecting metrics, tracking your work as you develop a model, debugging code to execute training runs, or understanding model behavior. What you're welcome to do is to select the radio button that corresponds to your answer. We do ask that you select one choice by design. And what we'll do is we'll give attendees sufficient time to respond. Again, we want to find out what your most pressing non-data related problem is today. And again, from top to bottom, just to recap the choices: tuning or selecting hyperparameters, defining or selecting metrics, tracking your work as you develop a model, debugging code to execute training runs, or understanding model behavior. Again, we'll give attendees just a few more seconds to respond, and then we will indicate how you have responded. Among respondents, the two most prevalent are, and I don't think it's because of where we've positioned the choices. I think the two most prevalent actually are at either end of the list of choices: tuning or selecting hyperparameters. So those are the two. That's one of the two, and the other is understanding model behavior. So I would say of the two, understanding model behavior is the greatest challenge, but close second, tuning or selecting hyperparameters. So with that in mind, we appreciate you responding to this first of three polling questions, and we will now continue with our webinar.
Excellent, thank you. So thank you for your answers. And in fact, your answers really align with the signals we heard in our market interview. And one of the first issues we heard is this idea of hyperparameter optimization is really important in that for specific models like deep learning models, a very fractional improvement is a game changer for enterprises. And therefore, having a robust optimization system is of the essence. Another pain point we heard is the fact that companies hire many experts, and these experts come with a variety of tooling expertise. And therefore, they want them to hit the ground running. They don't want them to relearn their expertise across a different tool stack. So the ability to have a system that allows these experts to actually hit the ground running, start modeling, bringing their expertise, regardless of whether they're trained on a particular stack or the other, is incredibly important for enterprises. And another, and to round it up here, a third point of interest for enterprises is collaboration. With companies moving from like central or decentralized approaches to having, as I mentioned in the earlier slides, expertise across the tool chain, being able to have a common horizontal platform that allows modelers to collaborate is really the name of the game for enterprises to adopt more modeling. So what do these problems that we talked about earlier really pointed to in terms of a solution framework? Modeling is siloed. Then we need to track in an organization to be able to drive productivity in the enterprise. Modeling requires a lot of trade-offs and decisioning. So performance is going to really require the ability to visualize what transpired in the learning process and analyze the results. And that's where understanding what happened to the model, as you all responded as a key area of the need, really comes in play. And then modeling is incredibly difficult to get right. So the ability to seamlessly iterate between training and tuning, and not only as you build your own models, but as you collaborate with your team, is of the essence. So as we look at these solutions, essentially, we come to this modeling pipeline element of the machine learning operational lifecycle. And the modeling pipeline is really about, as soon as you have that data, you get into this place of analyzing your feature selection, doing some preliminary training, possibly maybe choosing a specific or deciding between architectures of model, evaluating the results, going back to doing maybe some basic tuning. And then as you get to closer to an ideal model, maybe fire off a hyperparameter optimization tuning to get the best possible result. So that entire iterative life cycle of the entire MLOps chain is really the modeling pipeline where SigOpt solution is focused today, and offers you really the ability to guide you in the decisioning as you build these models. So this is how it looks. It's really tool agnostic. It integrates into any cloud infrastructure, and it essentially offers you the ability to manage your experiments, optimize your models, and build all of that at scale. We're going to get more deeply into how this works with the actual best practices guide that Jim will walk us through later. But essentially, the ability to transcribe your entire modeling process, the ability to filter what transpired in every training run, in maybe a feature selection run or in an optimization experiment, being able to also visualize and compare different runs that were maybe conducted to respond to different strategies and understand what is the best ideal strategy to move forward. And then lastly, this concept of seamlessly going back and forth between training and tuning that really allows you to reach the best model in an ideal timeline. So essentially, in summary, the benefit we offer today is this concept of being able to retrace and reproduce your modeling decisions with perfect recall, being able to train and tune seamlessly and decide when you really want to do one or the other, or in an iterative fashion. And then lastly, really learning and understanding what happened in the modeling process through interactive visuals and custom dashboards. This solution has been deployed by leading enterprises in various industries. We've seen 30% productivity boost for a global consulting firm across a 3,000 modeler install base. We've seen 8 times faster experimentation for Two Sigma, a trading firm, in their strategies on how to trade. And without further ado, I want to hand it off to Jim so he can show you how this works and what are some of the best practices around modeling and where SigOpt can empower you today.
Well, thank you very much, Faye. I think before we hear from Jim, we do want to pose now our second of 3 polling questions before we hear from Jim. Thank you, Faye, once again. And our second of 3 polling questions asks, which tool or tools do you most rely on to track training and tuning runs today? What you're welcome to do is select not only one choice, but you can actually select multiple choices, because we do want to find out which tool or tools you most rely on. So you can select the choice or choices that correspond to your answer from top to bottom. The choices are you hack it together, or if there's no specific tool. From moving on down from that top choice, we want to move on down: ML Flow, Weights and Biases, Comet ML, Neptune, or Other. Again, you're welcome to select the choice or choices that correspond to the answer to your question: which tool or tools do you most rely on to track training and tuning runs today? And what we'll do is give attendees sufficient time to respond. I would note already, and we do appreciate your candor in answering that, I would say an overwhelming majority have indicated that so far you either hack it together or don't use a specific tool, or other than those listed. But I think the point is that you've come to the right place here in joining our webinar, because clearly there should be an alternative to either hacking it or having no specific tool. So with that in mind, really appreciate your taking the time to respond to our second of 3 polling questions. At this point, it's my pleasure to turn the floor over to Jim.
All right, thanks, Joe. And again, thanks to everyone here and to MLconf for hosting us. I'm excited to go into some of the stories and best practices for building a model, and hopefully can tackle some of the challenges that you all indicated in the polls. But again, if not, feel free to add questions in the Q&A or follow up with us afterwards. We're always happy to talk modeling and optimization with anyone in the community. So what I'll be talking about today is best practices and using SigOpt for an example. And as you all probably know, there are many, many different important steps in the ML modeling process. But we're going to focus today on a few key areas out of those. And those are using metrics to make decisions about your modeling process. And that includes using metrics to kind of understand your model behavior as well, how your model is accomplishing certain goals. Tracking your runs, your training runs, so that you can understand all of that. And then finally, hyperparameter and architecture optimization. And architecture can be generalized as a type of hyperparameter or parameter in your model. So we're going to focus on those big three, although of course both we and probably MLconf would be interested in what other areas you'd be interested in talking about in the future. And those three things that we're going to focus on really build together in the sum is, or the whole is more than the sum of its parts type of way. Discovering computing metrics, in order to track those well, you need the tracking and analyzing piece. And though both of those will form the foundation for how to do hyperparameter and architecture selection. And we'll get into the best practices of how to select those as well. Rigorously tracking your training runs means making sure to track all of the things that go into a model, from parameters to your data set, features, system information, all of those things, and then being able to understand the results. So that's what we'll be looking at. And before I go into some of the details, I wanted to set the stage a little bit. In my previous job, I helped run the spam and fraud teams at Yelp, and so I thought it would be appropriate here to use a payment fraud example. That example here will hopefully be familiar to people, at least passively, and it makes a good example to talk about some of the complexities and trade-offs in modeling. We'll be using this synthetic data set called PaySim, which is modeled after real transaction data, and we'll be using some metrics that use the amount here, which is quote unquote in local currency, but we'll just be talking about dollars. And this data set is really helpful because it contains millions of different rows, some interesting features and that sort of thing. But again, we'll be focusing on a few of the different key aspects in the modeling process. And the second stage here is that we'll be using some example code in a notebook that we've put together to show off the ways in which you can use SigOpt. There's lots of different ways to accomplish the best practices that we'll be talking about, so hopefully this is going to be useful if you're using some of the other libraries out there. But we'll be using Jupyter and Python to work with SigOpt. SigOpt can be used with any infrastructure or library, as Faye talked about. We also offer an on-prem solution for those looking for that. And I'll be demonstrating how these best practices fit together. In the future, we'll be doing a deeper dive into this notebook. But for right now, I'm going to be showing you kind of glimpses and peeks just to show what's going on. We'll be first talking about metrics, because that is one of the first steps in really understanding the behavior here and a best practice to really understand them. You know, advanced modeling typically is trying to meet many different business environments simultaneously. And so asking a business owner for a single metric, much less a commonly used ML jargony type metric, almost never works. What do I mean by kind of common ML metrics? Well, these are the metrics that are often used in a general way for models kind of across the board. And don't get me wrong, they are really useful metrics. And some of you may be thinking of some already. They are really useful for training and kind of understanding general model behavior, but they're not going to help you communicate with your business owners. And what I mean here is things like precision, recall, accuracy, area under the curve starting to get a little bit more advanced. These are all helpful for understanding model behavior in general. But when talking with business owners, we believe it's really important to have conversations about the things that the business owner cares about. And instead of just relying on these academic metrics, you'll almost have to run kind of a discovery process. And when I was working with fraud, that was talking with business analysts, with product managers, with customer support folks, kind of all the people that might interact with your model in one way or another. You can ask your local product manager how to run a discovery process, but basically you'll be needing to ask a lot of different questions about how the model will be used and what their kind of greatest hopes and fears are for it. So if you all can think about the types of metrics that you might be wondering about in fraud, hopefully some of them will be here on this list, right? So you can see many of these metrics have a dollar sign in them, and that's not a coincidence. Many times metrics are there to have a business impact, and many business impacts are measured in this way. But I've also seen frequently kind of customer connections with businesses in previous roles, or success rates or click-through rates. All of those are a little bit more tied toward the business goals than they are the model itself. And keeping these metrics in mind and having a way to compute them during your training is really important. One of the ways that I found useful in talking with business owners about these metrics is trying to give kind of extreme examples. And as one common way that you've probably seen before in talking about the precision and recall trade-off is to ask a business owner. In this case, I've kind of set up Faye here, even though I know she's more experienced at ML than this would indicate. But she'll be my foil here today. So I might ask, what would you like the model to do? And the answer comes back, well, I want to catch all of the fraudulent transactions. And I can say kind of cheekily, well, that's easy. I can catch everything by marking everything as fraudulent. And hopefully that elicits the response and the realization that, oh, no, the goal isn't exactly to catch all fraud. There's some kind of trade-off between catching valid transactions as well. You don't want to lose any valid sales. So we need to talk about trade-offs. And balancing those false positives and false negatives can be part of the art of developing these metrics. So how does this actually get done? Many metrics are going to invariably kind of crop up, so it's helpful to log as many of those metrics as you can from the start, especially business metrics that you know about, so you don't have to go back and reconstruct what your different models, what the behavior of your different models was. Many of you talked about wanting to understand the behavior of your models, and so using a centralized place to look at your metrics is one of the things I really recommend in doing a best practice. Having a consistent method like this record metrics function and can be a way to do that. Again, we're not going to dive into too much of the detail here, but what I want to point out is that we are logging metrics, both the general model and academic metrics like AUPRC and F1 score, but down here at the bottom, we're also starting to log some business metrics as well. And we do that by going through the fraudulent transactions that we have in our record and kind of adding up all of those so that we can have a total and get some kind of understanding of the business impact that your model will be making decisions on. And as you go through this, you might realize in talking with a business owner that you have a better understanding of the business outcome. Maybe in the case of a false negative, missing a fraud, you're not just going to have a business impact of losing the money from that fraud case, but it also involves customer success, and maybe you end up losing twice the amount of the actual transaction. But it's even worse if you deny a valid customer from being able to make a purchase because they have a terrible experience and never come back. And maybe from looking at data, which again you can partner with your business owners on, you determine that has a 3x loss on that customer. And so in your kind of centralized place for metric keeping, you can add in a line here of SigOpt kind of log. You want to log the metric of, let's say, total total dollars lost for all of your transactions. And what that looks like is 2 times the fraud loss plus 3 times your valid loss, the loss of your valid transactions. And putting that all together and creating this metric, then you can use this function to consistently record these values over time. And hopefully, through tools like SigOpt, if you need to go back and rerun previous model trainings with an updated metric function, that will be straightforward because, as we'll see, you're going to record all the information from your runs before. So what about this log metric function? Where does that go? From our experience, like Faye said, we've talked to many modelers, and in my own experience, oftentimes those metrics are printed out or kind of squirreled away in different Jupyter notebooks. And if you're lucky, through 5 minutes of scrolling and scrolling, and if you haven't overwritten it by an iteration that you've done subsequently, you'll eventually find that metric kind of printed out somewhere. Maybe one step above that, as many may have taken a poll of hack together solution, you might end up writing this in a Google presentation or spreadsheet. We've seen actually lots of handwritten notes kind of tracking the best model that has been seen so far. But there are obvious problems with all of these. They're not in a centralized place. You can't really sort or do any sort of comparisons with them. And there's a problem in transferring this information from when you built the model into a tracking system. So this is one of the things that we've tried to introduce. Now we've jumped into SigOpt's web UI. And this is a place where we've seen a series of runs, of training runs, over this synthetic data fraud set. And you can see that there are pretty standard ML metrics here. If we slide over, like AUPRC, an F1 score, but you can also see that we've started to log these different values that have a business impact. And they don't need necessarily always to be logged and forever. We do have an element of flexibility here that you can add metrics as they go. But with this table now, you're able to kind of organize, sort, and look at and filter all of your runs that you've seen before. We can also start visualizing this information on our analysis tab. That's the next step, right? So taking a look at all this information across different dimensions, this is a visualization tool that we call linked scatter plots. So what it shows you is different metrics like AUPRC on one axis compared with other metrics, perhaps these total dollar lost on other metrics. So you can start getting a sense of how your model is behaving with respect to the metrics that you've started to track. You can see here that we have a lot of different models that have performed, frankly, terribly. Way down here where there may even be a bug, which these metrics can help you identify. So again, one of the things that we can do down here is take a look at the AUPRC and say, hey, you know what? We really want these things to have greater than a 90% accuracy or AUPRC. And let's filter those and take a closer look at what that behavior looks like. So we're able to take that table of centralized information and translate it into valuable analytics and plots here. And you can see that the AUPRC isn't exactly aligned with the total value lost. And so the way that your model might be behaving here is that it's trying to catch the most number of fraudulent cases instead of something more like the business owner wants, such as the total dollars lost. And for way outliers, you might be able to get a sense by hovering over it and seeing where this point lies across other dimensions. That some have really poor behavior across both the false positive and false positive and false negative rate, while others have pretty good behavior on, say, a false negative rate, but poor behavior on a false positive rate. So being able to dive into those metrics and understand the types of behaviors your models are seeing Again, this will work across all different model types, can give you a better understanding of that model behavior and the types of parameters, hyperparameters, and even optimization metrics that you might need to tweak in order to get better business performance. One thing I'll say here, though, is, you talked with the business owner, you got this total dollar lost, but I don't want to claim any silver bullets here. Don't fool yourself that this is the only metric you'll need to report. In my experience, even if you do report this kind of total dollars lost that you've agreed upon as your ultimate metric, inevitably people will want to dive into it and see how it's being constructed, how many people are being affected, how many users, how often. There'll be a lot of sub-questions that, by tracking all of these metrics kind of at once, leads to really effective conversations. You could put together that information quickly without having to go back for 1 or 2 days for every single question that your business owner asked you. This metric selection is a really important aspect of the model training process, and eventually, as we'll see, really dramatically impacts your effectiveness of hyperparameter tuning. The next thing we'll be covering is tracking your training run. So you might be thinking, hopefully you're thinking, if rigorously tracking your metrics is such a good idea, then shouldn't thoroughly tracking everything be even better? And the answer is yes, especially if tracking that additional information comes very cheaply or almost for free in this case. The next question that you're going to get after you agree on one of those points as a trade-off place is, so how soon can you get that model in production? And you'll need to know things like what data set you used to train, what features you used, the parameters that you used, any operational configurations that you use, and much more. And this information isn't just used to finalize your model. It's often used to make sure that you as a modeler have explored all use cases. Faye talked a little bit about the communication and collaboration bit here. And from our experience, a model doesn't, it takes a village to get a model into production. And metrics ranging from those business metrics to maybe latency to other concerns all kind of play a role in here. So making sure to track and understand all of this information becomes really important in effective model development. And as Faye mentioned, we think it's really critical to have access to different model types in the same place. We don't want to lock up your data in one tool that only supports one particular library or framework. We're using a lot of Jupyter Notebook here, but we would be able to build models in other types of infrastructure or services and still have it feed into SigOpt, so you can compare those all in the same way. To do that, we provide a set of generic REST API calls, and currently a Python client with more clients on the way to improve the convenience and accessibility for these. And they work, all of these things will work the same, whether you're using an XGBoost model, Keras, sklearn, or some of the others. So what does that look like in practice? We want to see how those different model types work in different ways. So we can add new a linked scatter plot here with the type of the model and different metrics that you might care about, again, like the AUPRC and the total lost. So adding this gives you an ability to see across different model types. We have another model type here that we're using for another purpose, but if we look down here at the XGBoost classifier and the Keras model, you can see that they have different behavior across these different metrics. XGBoost classifier has some clunker models down here, but generally they have a pretty tight clustering toward the top of AUPRC, although they're not as consistent with this loss value. On the other side, looking at the Keras model, we see more spread across different things. And as Faye mentioned, hyperparameter selection has such a big impact on models like deep learning that we have some really bad models over here that, again, may just be impact of operational problems. So tracking those different model types really important to understanding the behavior in your model, and you can segment those out in different ways according to your needs. So about making all of this tracking easy, let's take a look in our notebook to see how those are actually done. I'm going to scroll down here to one of our XGBoost models to see what that looks like. And I'll go over a couple of these things, but you'll notice a pattern here. So first, we'll see things like logging our data set. And the way that that works is you're logging a reference to your data. We don't restrict the way that users store their data. We don't carry a copy of their data in case there is ownership, privacy, or legal restrictions on it. But we allow you to give a reference to it. Often that's a reference to a variable in your notebook. Sometimes it's a URL to where it's stored in S3, or a URI for some internal type of storage. We recommend, as a best practice, changing your data set as you manipulate it, as you add in missing values, do feature engineering work, add in features. Changing and versioning that is a topic for another conversation, but which we try to support by using these references. Secondly, you'll see that we're logging this model type. And again, we're using a reference here. So in this case, it's a class name. But it can also be things like an architecture, like ImageNet or DLRM, or different types of external models that you might be wanting to use through enterprise solutions like SaaS. Unlike many tools, again, we don't assume, like, this is for your information only. We don't assume or change our results based on this. We provide a general interface so you can do all types of modeling work. Next here is metadata, and we provide these so that you can store additional key value information that we have not maybe even thought of yet. Storing features or metadata about your training information can be a useful way. We've also seen this be really handy to store information about which cluster or which computer a certain operation ran on, so you can go back and fetch the logs. Managing distributed training can be, again, another topic. But all of this metadata will be associated with your run and is also filterable, sortable, all that good stuff that you saw in the web UI. Finally, we have one that looks a little bit different, this SigOpt get parameter. This logs parameters, as you might expect from the pattern that we saw above. So get parameter logs parameters, but also does something special during hyperparameter optimization. Instead of just using the default, which you can specify here, during hyperparameter optimization, it can provide you better parameters that try to optimize the metric that you're shooting for. So this one does a little bit of both. It both logs all of the parameters that you're using and gets you prepared to take advantage, using these best practices of other techniques that can improve your modeling. Down at the bottom, we've already kind of recorded how to log our metrics just using the log metric function that occurs in our general record metrics function down here. The second example that we have, just to show you that this does work across different modeling, is with a Keras run up a little bit further in Notebook. So as you might imagine, setting up Keras is very different from XGBoost. We have to set up our different layers. But we are still able to use the same SigOpt functions, get parameter for our log learning rate, the number of epochs we want to run, our batch size. So all of those things are the same, and it works in a generic way so that we can optimize our Keras model in the same way that we optimize our XGBoost model and track it in the same way so that we can compare them against each other. One special thing I'll point out here is Keras allows callbacks that allow you to kind of introspect the training process. And if we scroll up to look at that callback function, you can see we have another SigOpt function here for logging checkpoints. What checkpoints allow you to do is to see a training run while it's happening. And we'll get into a little bit more details of what that means in a minute, but you can use this checkpoint to kind of log your process along the way. One thing I'll note too here is that with this callback function, we have a generic SigOpt function call. You're not having to thread your context through a bunch of calls. We're trying to keep state in a kind of crazy way. SigOpt tries to handle that for you by using some of these special Jupyter context, or if you do want to do some of the more advanced work, we use Python context management to kind of create runs and give you the ability to do that threading or passing of context if you're in a distributed setting. So down at the Keras model, you'll see the way that we kick off a run is with this %run command. And what this does is allows us to kick off a run, set context for where we are, log all of these parameters in the proper place, and sprinkle that logging throughout your code in a way that doesn't make you need to reorganize everything in order to take advantage of these best practices. And so what does that look like when it kind of comes out? Well, you can see here that when we start a run, you'll get a link to our web dashboard as well as all the logs here. And if we click through to that link, you'll see we have information about the different checkpoints that we talked about. So this is our F1 score, our loss function, our validation loss that evolve and change over time so that we can start getting a sense for how this is converging. And this information is live during the training process. We can also see as that run wraps up where our training lies, given our metrics down here, where our metrics lie with respect to all of the other runs that have occurred in your project. So not only are you getting a sense of maybe a mediocre, in this case, AUPRC, but you're getting a sense of where that lies with respect to the rest of the models that you've trained in your project. Having that context makes understanding your model behavior a lot easier, because oftentimes there is no absolute metric that you want to hit, but there is kind of a relative one. One thing that we recognize too is that a lot of times there will be kind of qualitative information that you want to add on to your run. In this case, we have a pretty smooth training curve, but you can imagine in other cases, those training curves might look a lot more spiky and a lot less, you're a lot less convinced that they are converged. Convergence, best value, like promising looking runs, those can all be very subjective measures of a run. And so what we've tried to do to handle that is add the ability to tag runs up here. So we can add converged, we can add a new label about any other property that we want. Click through on this. These tags will allow you to sort, filter, and all of those things on the table that we saw earlier. I'll mention too that the %run works in a Jupyter notebook, but we also provide a command line capability to do that as well. SigOpt run does the same thing in wrapping context around your Python file, and it will run that with the context and output the same sort of information that you saw here. If you have opted in to this practice, we can optionally store your logs and the code that you used either in your Jupyter Notebook cell or in the file that you're using to build your model. And being able to quickly look and see whether your code has that nagging bug in it or whether you finally resolved it, and whether that is the thing that's causing a metrics problem can be much easier to debug. So that's the best practices. And one thing I'll say, in terms of the other thing this allows you to do, as an engineering community, we know that the magic numbers or random numbers or strings are not the best practice. We don't know where they came from, what they mean, and guess what? They're not the best practice for model development either. So when using this tracking information, you're calling out and naming those impactful constants and tracking them. That helps you document your code, not just within your code, but in another place that people can reference and understand and refer back to when they want to do this training again. So you're at least calling out those magic numbers and why they're there. We've talked a little bit about sharing this information with a web browser and that sort of thing. So one question I want to pause in here is understanding how your team is structured, so that we better understand trade-off in topics between diving into individual hyperparameter tuning versus helping a team understand that process.
Thank you very much, Jim. And as Jim noted, we're ready to pose what is now our third of 3 polling questions. We want to find out, as Jim mentioned, is how your company's modeling team is structured. And what you're welcome to do is select the radio button that corresponds to your answer. From top to bottom, the choices are small and centralized, that is fewer than 10 modelers, mid-size and centralized, between 10 and 100 modelers, mid-size and distributed across organizations, between 10 and 100 modelers, large and centralized in a single team, more than 100 modelers, or large and distributed across organizations, more than 100 modelers, or none of the above. And again, what you're welcome to do is select the radio button that corresponds to your answer. What we will do is give attendees sufficient time to respond. We'll then briefly summarize how you have responded, and then we'll consider your response as we continue our webinar. The other thing I do want to note is we have set aside some time, I think most likely during the last 5 minutes of our webinar, to address a couple of great questions we've received from attendees. But in the meantime, I do want to note that among respondents, the leading response is small and centralized. That is fewer than 10 modelers. That seems to be the winner in response to this third of 3 polling questions. So again, so far the leading response, and this is by a significant margin, small and centralized, once again fewer than 10 modelers. And now we will return back to Jim.
Thank you, and thanks for all the response here. Super interesting. So last, we're going to dive into parameter optimization, and I can hope you can see why this is one of the last steps here, because we had to do a fair amount of work to set ourselves up with best practices in order to take the most advantage of the optimization process, as we'll talk through it. So what do I mean by optimization? From the polls, it looks like many of you are familiar with the concept, so I'll try to keep it brief here. But now that we've documented our magic numbers, the common answer for how you got those numbers in the first place was, well, I played around with this a little bit, and this was the best one. What does the best one mean, and does it meet all the business constraints? Well, you cross your fingers. But these days, we have a much better way of doing this, and it's called generally called hyperparameter optimization, or HPO sometimes. So the way hyperparameter optimization works is parameters are selected in order to improve a metric. So SigOpt is able to intelligently select and suggest better parameters, better magic numbers, if you will, that will try to minimize or maximize, depending on your context, your metric. So from a modeler's perspective, we'll need to select the parameters that we want to change and kind of hook up our model so that they can be easily changed. And as we discussed, we're in luck because we have already done a lot of that hard work in using our getParameter function here. In our model training, we have our getParameter here. And so this is one of the values of best practice, right? By starting to think about our metrics early on, by starting to record them in a thorough way, now we're much more easily able to transition into hyperparameterization and not just noting that there are variable parameters here, but starting to be able to optimize them. So the next step is that we are trying to pick parameters to optimize a metric. So we need to report our metrics. But luckily, thanks again to our best practices, we are already doing that metric reporting. And I'll swing up to our function, which was doing our metric reporting for us. And as you recall, we added functionality to do metric recording, both of a log metric of AUPRC and of our total dollars lost. So all we need to do to kind of bring all these elements together is to define an experiment that says we want to pick one of these metrics, one or more of these metrics to optimize, and we need to give a little bit more information to our optimization process to tell it for different types of parameters, what is the range or the bounds that we're allowed to move between. Many parameters have these ranges as well as type information that we wouldn't be able to derive from simply calling get parameter. So we define it here in this %% experiment, which gives us an experiment that we can look at. And in our metrics section, we can both talk about metrics that we want to store during the experiment, as well as metrics that we want to optimize. And when we are optimizing, we specify whether we want to minimize or maximize. Obviously, in the case of AUPRC, we're trying to maximize that. So if we move through this, we're able to get a new experiment, and instead of a %% run, we have a %% optimize. And what this does is creates multiple runs in that loop that I talked about. Each time we run through this code, we create a new training run with new and improved parameters, and then report the metrics that those parameters produced in order to give us a better suggestion the next time. How many times do we do that? We use our observation budget. A quick tip there is usually we recommend about 10 to 20 times the number of runs of the number of parameters that you're optimizing. In addition to integers and doubles, we also support categorical parameters. So if you're picking the type of gradient descent or function for loss, you can do that through a category, as well as some of the other functions. There was a question of how to best do that optimization, and two tips I'll provide there. One is making sure that learning rates are searched for in the log space. So typically things that have a range of 0 to 1, you want to be able to search in log space. That's why we've transformed, in this case, our 0.1 rate to a log in order to put it into SigOpt. We've recently launched the ability to do this automatically, but at a high level, making sure to search over log space here. And number two is to make sure to go through and read the documentation for your model. We often recommend trying 1 or 2 different parameters to kind of get started and see what the impact is on your model to get a sense of commonly used ones. But since we support up to 100 parameters, oftentimes if you have the compute capacity, you can throw all of the parameters in there with the ranges that are appropriate. And unlike a grid search, which would have millions of points potentially to test everything, this intelligent optimization will get you good results in much less time. So that's what this looks like. And if we run this XGBoost optimization, we can start to see that our runs are being kicked off and started. And we can click through to look at these runs. They will have the metrics that we care about, as well as the information about when and where it ran. This one, it looks like it's still running, but if we refresh that over time, we'll see that it completed with all of our metrics, and we're able to understand that. Going back to the actual experiment, we can see that over time, we can get more and more observations through that process as more runs come in. And what that will look like over time is an improvement in your AUPRC or whatever metric you care about as the parameters get better and better. We'll also give you your best value that you've seen so far. And in the end, you won't be using magic numbers anymore. You'll be using efficiently found best numbers. So overall here, we've set ourselves up well for a best practice. And automating this HPO process means that we're going to get better and more understandable results for those magic numbers that we can then have a history to look back to as to what we were trying to optimize and how we did it. So these are the 3 best practices. They really add up to a great modeling procedure. One thing I'll say that we haven't really had time for is, in the real world, you're often not doing this optimization and then picking the best point blindly and putting it into production. That's unlikely to happen in the real world. When I was developing fraud models, all kinds of new constraints popped up, like latency, the false positive rate, the number of new users that are impacted, all of those things. And so we provide a number of advanced features on our optimization framework to allow you to do things like multi-metric, to balance things like training time and accuracy. You can see a Pareto frontier of best points across 2 different metrics as you optimize across multiple metrics. If you do have a tight bound due to business circumstances, and you can't go more than, say, 30 milliseconds for your inference time, you can implement that in SigOpt through that interface that I showed you, and it will try to find points that meet that criteria, either with metrics that you're optimizing or metrics that are not optimized. Maybe you don't care about latency as long as it is past 30 milliseconds. And we're able to do that too. Please reach out for some more information on these advanced features, or they're all available for documentation on our website. And so with that, I wanted to wrap up and say, all of these put together, we think offer a really strong package for modelers. We don't believe that a complete AutoML solution is really viable for modelers out there. So we're really striving to put tools in your hands to automate the boring stuff, but to give you the information and feedback that you all need to understand your models, communicate with stakeholders, and amplify your impact. So with that, I think I'll wrap up. Thanks, Joe.
Thank you very much. Really appreciate the opportunity to get together. We received great questions from attendees. I would acknowledge, given the timing, we'll plan to follow up on these great questions after our event. We are providing access to the tool we've described. Is that correct, Jim?
That's correct. We've sent out invitations to our beta program. I will emphasize it's beta, so we love the feedback, and we're improving things, literally as we speak. So all attendees will be able to access that for their own models, to be able to do their own optimization and tracking, and to feel free to reach out to us for support.
That sounds great. Thank you so much, Jim. So once again, want to thank attendees for joining us for our webinar, Best Practices in Hyperparameter Optimization for Developing High-Performing Models. Also want to note that this webinar is brought to you by MLconf in partnership with SigOpt. And finally, want to remind attendees to sign up for our upcoming MLconf online event. That's on November 6th, so more information is available on MLconf's website. Really appreciate everybody joining us for our webinar. We thank you for your time, and we hope you enjoy the rest of your day.